Good morning, class. This is your instructor for Mathematics 1, Business Mathematics. For this, we are going to be studying exponential and logarithmic functions. As you can see, I've already given you this chapter, so it's uploaded in Google Classroom. So what we are going to be studying today, since this chapter is pretty long, I'm trying to be precise with you a bit. Basically, exponential is something which is does not have a constant rate, rather it is raised to the power of something. So basically, when you're saying that something is growing exponentially, it would mean that there's a proportional rate of change which is positive, and it could decline also, but then it was not going to be exponential increase. For an exponential increase, it has to be in the power of something, and it has to have a proportional rate of change, and that rate of change has to grow. So I'll give you an example here of a bacteria. See, we have the chapter outline. We're going to be doing the logarithm in the next lecture, because I'll be breaking these topics down lecture-wise. You can see that for simplicity is just to have something a very basic idea. Let's just say that there's an hourly rate for which bacteria is growing. We know that bacteria can multiply asexually. So for, let's say, 0 hour, we have a function which is fx, and we can input have an input, and then we can have an output. So for an input, let's suppose we say that there's 0 hour. That means that at the moment it is just starting, it's just having the beginning of something. So it is going to be giving us an extrapolation. So this word I'm going to be highlighting, extrapolate, means that we are going to be estimating based on the initial results that we have. So in the initial hour, we have, let's say, 1 bacteria, and as the time would go by, so there is a constant change. Now this is a linear, you can say there's a linear relationship from the initial value. So it's basically 0 and then plus 1. So it could be, then again plus 1, again plus 1. So we have different values of x in this case. But it could be exponential, because if I were just asking you about the hour that is changing, so you can just say that there's just x and then plus 1. So it is just x is 0, and then plus 1 means that it is x plus 1, and then again plus 1 would be x plus 1 or x plus 2, and then x plus 3. However, there is an exponential. Over here you can see there's this constant change. So when we are observing something which is constant, then it is a linear function. That is that is the difference between having something as a constant function and then having something as an exponential function. So exponential would be that there's a proportional rate of change. So for instance, if you say that in the initial hour, the bacteria, there was just 1 bacterium basically. So use the plural here. It means that basically we are going to be studying about the property to divide, and then first on the initial level, it's going to be dividing. So it would, from 1 it would become 2. That again, there's a constant change. Now for the first hour it's going to be 2. For the second hour it's going to be again 2 raised to power 2. So that means it's in exponential form now. Now you can understand the difference between being having something which is constant and having something which is exponential. Exponential would be a proportional rate of change, so you are going to be raising it to the power of 2. To know that when you're changing the rate, that thing which is being changed is known as the base, which is denoted by b, and b has to be greater than 1. You cannot have b as 1, because then the base would not change. So if I say that b is equal to 1, then 1 raised to power 2, 1 raised to power 3 is just going to keep giving you 1. So that means the bacteria is never going to multiply more than 1 time. So because anything that is multiplied by 1, and when 1 multiplies by itself, it just yields the same answer. And we want to have a rate which is going to be giving us a proportional change. It is enhancing with a constant time change. So now constant is a linear function, but the rate is proportional to it. So now you can just simply say that this is 2 raised to power 1, and this is 2, it's just 1 raised to power, at this time it's just 1, and then you're having an exponential change, so it's going to be 2 raised to power 1. Initially it is 2 raised to power 0, and you know that anything which is exponentially expressed in terms of 0, you get 1 out of it. So it's 2 raised to power 2 and then 2 raised to power 3, and then that means that this portion is basically your variable x. So it has to be in the there has to be a constant value, which is 2. In this case, you can see all these numbers have a constant, which is 2, and then x, you raise it to the level of x, so you get so 2 raised to power 0, and then raised to power x. When x changes value from 0 to 1, it's 2 raised to power 1, and then 2 and 3, so it would be giving you an 8. So they say that within 24 hours, so because it is increasing at a rate that it is twice, and then it's thrice of that, and then it's tetra and penta, and going onwards, such that the value is going to be giving you in that cells that are multiplying, giving you value in terms of millions. So that means that within 24 hours, when we extrapolate, that means we are further extending our analysis, because we are not going to be recording, because this is the value of one bacterium. So we can have subsequently different bacteria, we can just have, this is the case that within 10 hours we have over 1,000 bacteria. So this is from one bacteria we can have so many. So for 2 and 3 and successive bacteria we can have as many, and then we can extrapolate, means that we can estimate that we will be getting 16 million. So in this section we're going to be evaluating the functions and find the equations. I'll be just reading it out because see this since this chapter has many parts, we'll be just having the you can say the close look at the entire chapter, initially the entire section, and then in the subsequent lecture then we'll be looking at the other things more closely. Since this is the initial time, they're just examples that I just really want you to do before we can go to the next lecture. So now you see that this is a function which is 3x plus 4. In the exam you can see that this is a slope and this is the intercept, so it is constants. This is a variable, but this variable is in the base. For an exponential function you cannot have anything in the base, it has to be raised to the power. So the slope tells you that the output increases by 3 each time. What does this mean? It basically means that if it is anything that x assumes, any value that x assumes, multiplied by 3 times. So the value would be increased by 3 times, which is actually a constant number, and the input would increase by 1. It means that from 0 to again 1, and then from 1 to again 2 to 3 and 4. So the input is actually increasing by 1, but the output would be giving you an increase, which is by 3. Okay, so now then you can just add up the whole equation, but this is basically an example of having a linear function. It is not an exponential function at this time. Let's just go over to the exponential function. In this case, let's just say that there's a talking about a population. Anytime we're talking about a percentage, something which is expressed in terms of a rate, or changing per second or per hour, or just giving you some value expressed in a numerator and a denominator. So that means that it is rather than having a constant change, is some percentage which is changing per time, and that is rising. it is not a constant change. So that is going to be an exponential function. And the study has found that in the United States the population has doubled from 2009 to 11, and in 2011 it was 2.5%, and it was vegan, means largely that they're on vegetables, and it also means that they can have some of the dairy products but not all, adhering to a diet that does not include any animal products, no meat, poultry, fish, dairy or eggs. But to some extent it has some elements of the dairy, but not completely. So if this rate continues, vegans will make up 10% of the population, 40 in 2000. And this is basically exponential growth, because now the rate of change is not constant. I mean, it's not even rate, the change is not constant over the domain. So we'll be studying further what domain means. Domain is basically the whole base. Going from minus infinity to a positive infinity, that is basically the limit of the real line, the number line that we have of real numbers. And mind you that these all have to be real numbers, and we cannot have under root values in the end. So we need to have we can't have irrational numbers in this. So percentage change refers to a change based on the percentage amount, and that's a percentage. And exponential growth is so you have to, in order to be able to answer the questions, you should understand the key definitions. That exponential growth is increase based on a constant multiplicative rate. Multiplicative rate here, as you can see that now, again, that what we did in the previous example here, they have just gone down to further elaborate this excess changing value. So now there are two kinds of functions. One is a linear function so that you can simply express these answers differently into different columns. We start with an input of 0. So input any value that x assumes, and output is something that when an action has been taken over, so it could have an output either in linear form or an exponential form. Then there is something which is known as an exponential decay, and we have already mentioned this. I have already mentioned this to you in the previous class, and we have done this before. But the concept basically needs revisiting. It means that rate of change basically is declining. Why is it declining? Perhaps because the base is between 0 to 1, or it could be in some fraction form, although base is required to be greater than 1 for an exponential increase, but for a decay it could be in a decimal form. So it could be between 0 to 1. As you can see here, that it could be between 0 to 1. The function decays at a rate which is proportional to its size. So proportional to size basically means that whatever initially it was, again you're going to be comparing it from the base size, and then it will have an exponential times increase. So it's times basically. Rate would mean 1%, 2%, 100%. So 100% would basically mean 1 time. 200% would mean basically 2 times. Let's see, just getting stuck here. Okay, now so we have 2 raised to power x here. So you can see that now 2 raised to power initial input was 0, so anything raised to power 0 is 1 here. Sorry, this is hold on with the mouse here. And as you can see that for an input which is 1, you're getting anything raised to power 1 is the number itself, and then raised to power 2 is something just twice of that, or it's you can say that 2 into 2, so it is multiplied by 200 times, or you can it's 200%. You can say it's twice of that. Our class, to pick up from where we left off, initially it's just raised to power. Now you can understand the difference. You're just simply multiplying, there's just 2, 0 times, there's 2 into 1 time, and 2 times, and 3 times. Over here is 200%, 300% of the initial value. So now you get that the linear function will always be less than it will always be less than the exponential function if it is not in decay form. So now there's a linear growth. Again, the definition is important, that the original value of the range increases by the same percentage over equal increments. How is it same percentage? Like, the number is 100, 100%, and then again another 100 is 200%, again another 100 is 300%. So it's 3 times. So this is just by same percentage over equal increments. So it is just twice of that value. So it's increasing 300 times. So it's just the times of its original value. So this is the original value is 2 in this case, so it's times. And then we have the linear growth, whereas it is just, Okay, so now this is linear growth refers to original value from the range increases by same amount over equal increments. Now this is an incremental value. Why? Because you have 0 and then you have 2 into 1. So just one time instead of 100% change. And then this is 2 times in this case, but in the linear function it is just twice. Instead of saying that it's twice of that, you just multiply it with 2. So it's basically 4 plus 4 and you get 8. And then however, I just wait plus moving. Okay, so now as you can see that this is multiplied by itself over here, the answer will be the same. But as you can see that since this is going to be again the answer is just 200%, but this now again this will start increasing because this is at an increase, constant increase of percentage, whereas this is just a number which is sort of like a general increase by just 3 times just of just multiplying it by 2, so it's just 2 plus 2 plus 2, whereas this is just basically this is an addition sort of, and this is just a multiplication of 2 into 2 and into 2, so it would basically means that it is rising exponentially. So again, the range is increasing by the same amount with equal increments. The same amount as in is increase is addition basically, so it is increase, in this case it is addition because it is increasing by the same amount, so it's 2 plus 2 plus 2 plus 2, so it's increasing by the same amount. Over here the range is increasing by the same percentage, 200%, 300%, 400%, so it is can't really multiply 2 and 4, it is 400%, you're going to just have 2 again tetra times. So that is the difference, having the same percentage and the same amount, and this difference is quite significant. Now we have b greater than 1, like I said, this is a condition that you need to have, and a, b, x is basically, a is the initial value that you need to have, and is a real number. It has to be a non-zero number. If you have a 0 number, so it's just going to render the whole function as 0. Which we really don't need, because we need to have b greater than 1, and it could have any value which is non-zero, could be even in decimals. But b is a positive real number, and I've already initially explained to you that it is not equal to 1 because it will just keep giving value equal to its initial original self. So that means that if it is between this, it is decaying, and if it is greater than 1, then it is at a radius proportional to its size. So see that if x has these values, so you need to have corresponding values. So you already know that this is going to be an exponential function. So 2 raised to power x, to simply put in the values, is 2 raised to power. So anything which is raised to power minus 3 is expressed in terms of a fraction to undo the negative, so such that, if it is raised to power minus 1, you can just have half. If it is raised to power minus 2, you can have half into half. And it is raised to power minus 3 is going to be half into half into half. So that it is 2 into 2 into 2, as an denominator. So you're going to be having 1 by 8. So if it is like minus 2, again it's going to be 1 by 4. So anything which is raised to power 0 gives you 1. And then now it's going to be having exponential increase. And this part is basically, as you can see, this is 1 by 8. Going from, 0 towards the negative infinity, it is going to be giving you a decreasing trend. So raised to minus 1, minus 2, minus 6, this is known as exponential decay, that the value is going down from the initial value. So it was 0.5 and it's going to be 0.25, it's going to be, onwards. So let's just make a few observations. It's just simply the graph that is being drawn from fx raised to power fx being equal to 2 raised to power x. So let me just also have my calculator with me so that I can just better see what values we can have. Let's just calculator. Calculator. So let me just have that here. So let me just demonstrate that if I hope that they have a basic function of, okay, they do not have, so let's just say 1 by 8 comes to about 0.125, just to show you, and 1 by 4 comes to about 0.25, so it's a point, and this you all know this is 0.5, so 0.5 is greater than 0.5, 0.5 is greater than 0.125, so this is, the value is reducing. Now if you see, this is the function which initial value is from 0, so if the value of the function in itself is positive and it is increasing, so we will have from 0 to infinity. Whereas if it is decreasing, we can have from minus infinity to 0, because it will be increasing and going max to 0. And the values would never, touch to the 0 point. As you can see, this graph is approaching 0, but it is not exactly touching the main horizontal line. Why? Because we have base of 2. So anything, increasing to the order of, to the base of 2 would mean that this value cannot be, equal to 0 in this case. So as you can see that 0, 1 would mean that the initial x value is 0, and the y, or the the vertical axis, can have 1. And then for negative, let's see, this is minus 3, so minus 3 here, and 1 by 8 would be like, it's going to be somewhere 0.125. So again, since this is not negative, had it been negative, we would be just trying to plot it somewhere here and drawing it from here to here. So now this is going to be drawn here as, you can see this is 1 by 8, so 1 by 8 going to be coming somewhere around here. It's going to be 0.125, very low sort of, so it's minus 3, and it's going to be 0.125. It's going to become, almost parallel, joining towards the horizontal, joining to the horizontal line in the negative, side of the two asymptotes. So we have the, the domain as the entire value from a minus infinity to infinity, and the range is basically for positive values from 0 to infinity, like I said, and as now there are two conditions for x, that either x could be infinity or it could be negative infinity. So if it is infinity, we will be having, the function, as having some value from 0 and then approaching infinity. But if x is negative infinity, so in this case, you will be having a function which is going to be approaching 0, because the negative value is way, far, ahead of 0. So you have to approach 0. That is the ultimate target for having a negative infinity. And fx is, either always increasing because of being an exponential one, and y0 is the horizontal asymptote. It means that for y being 0, it means that it could be lying somewhere here. It could be here. For y0, it could be this. Now, initially, since all these values have some value of y here, so 0 would mean that it is lying somewhere on the horizontal side. So there's no rise. There's no vertical rise. So this is known as the horizontal asymptote. And the y-intercept is 1. For y-intercept 1, this is the initial value. So we have 0, when x is 0, that means that we have just the vertical value. And that value is 1. So, and then y could be 0, and then we'll have this value as 1. So if y is 0, then we just have the horizontal asymptote. Okay? So now again, this is another function. So you're going to be basically studying all the examples in order to make sense of the questions also, because there are almost a lot of stuff being covered in this whole chapter. as you can see that this is again a function of AB expressed simply. These are the conditions in the exam. If you're required to find out whether a particular function is an exponential function or not, you have to see whether all the conditions or all the criteria have been met or not. So if A is let's say this non-zero number that we have already discussed before, and A is known as the initial value, and B again is cannot be equal to 1 like explained before, and X, so domain again and range is obviously has to be greater than 0, or it is in negative if it is less than 0. So however, as already explained to you that B has to be greater than 0 and B cannot be less than 0, so do not confuse A and B together, because this is the initial value, but B has to be, it cannot be less than 0 in this case, but it can be between 0 to 1. So there's a difference between having something between 0 to 1 and having something less than 0, because having something less than 0 would not be exponential, it would be opposite of that. And exponential values basically Euler's rule, EULER, Euler's, you pronounce it as Euler's or Euler's rule. It has some value of 2.178282. I think they've given the value somewhere 718282 or 2.1782. Okay, it's going to be coming ahead. I just wanted to show you if I can see it somewhere here. But you can even Google this value. What is the value of E? Let me just Google that for you, so that for easy reference, if someone asks what E is, exponent value. So you should actually know what an exponent value is. It's 2.718282, right? So, and it is a constant. So there we go. Okay, so now the y-intercept is 0 to A and the horizontal asymptote. So now see that the terminology that we are using is intercept for y and horizontal asymptote is y is equal to 0. That means we are using the horizontal. When a question states something like horizontal asymptote, it automatically would mean that y is 0 in this case. And y-intercept would mean that that is initial value, just like we did the cost function. So if you remember the cost function, we said a plus bx, and I said that a is the intercept in this case. Intercept would mean that any constant value below which the graph is not going to go, or it's not going to be going or falling below that particular line. So if I say that intercept is 200, it would mean that the cost would start at 200. It's just, for example, you get the telephone bill in your house, and there's a line rent, which is a fixed cost. And that would be sort of like an intercept, after which all the costs would be increasing. They could be increasing exponentially also. If they tell you that the rate would be shifting up for every bar that you're using, so there's going to be a jump. So there's going to be an exponential constant change, and if it is inconstant, then we have to shift our function accordingly. For each constant shift, there's going to be a separate function. But till the time the shift is not occurring, as in from one consumption level to another consumption level, then we can say that the exponential rise has not taken place, because the exponential rise can only take place if there's a constant shift in the percentage change. So the bill would be having an exponential increase for every shift, and not before that. There's going to be a constant change. There's going to be a linear function in that. Now let's just see if we have done all the okay, now there's sort of like a an example in which and mind you, again I'm repeating this, that you have to do all the examples for your concepts. Again, the question arises how to not confuse exponential function from the linear one. Like I said, that b cannot be negative. In this case, you see that jx, b does not represent an exponential function because base is -2, which is less than 0. And like I said, that base cannot be less than 0. And in this case, it is 1/3. It can be in a fraction, but that could represent sort of like a decay. And but it is raised to power x, so it is good for us. And this is basically a power function. But do you really think there is exponential function x raised to power 3? If you look at it closely, you can see that this variable part is in the base. But as I said, that the base has to be constant, and in this case, the base is not constant. It's a power function. So do understand that there's a exponential function, power function, quadratic function, polynomials, and which are the linear functions. So in this case, it's going to be a power function. This can somewhat be, an exponential function. However, we don't know the value of x. It could be a negative value. So to some extent, we can say that this is, but this cannot be it. So the question is not which are the exponential ones. What they've asked us is which are not the exponential ones. So in the exam, you have to pay close attention to what's being asked. And gx and jx in this case, they are not the exponential functions. Now, which of these following equations represent exponential functions? This is just to try it for you. As you can see from here, even though they haven't answered this, let's just go one by one. Fx 2x squared minus 3x plus 1. Like I said, that this has the base, non-constant base, a variable. So you can just simply say that this is it's not an exponential function in this case. But they have asked us which of the following represent exponential functions. So we can just rule them out. And now this is an exponential function. As you can see that this is raised to power x and is lying between 0 to 1. And this is a linear function, as can be stated that you're multiplying it with the base in some constant value. And this is raised to power minus 2x. I would say that this is also an exponential function in this case. Because this is raised to power minus 2, or it could be, anything which is raised to power minus 2, or when it is raised to power minus 1 is 1 over 1. So it is over this and then again multiplied with its own self, 1 over this twice, raised to the power this, and then just multiply, and then you can just simply go over again to the example that we were doing, 2 raised to power minus 2, and anything raised to power minus 2 is, of itself multiplied twice. So if it is like this, then you can just simply of itself multiplied by twice, and then 109.5.6 into 109.5.6 and raised to power x. So, but then again, this is going to be a decay because it's not an increase. So you have to be very careful about whether it's an increase or an exponential decay. This is, again, I said it's not a real number. Under root is not considered as anything which is in a radical form is not a real number. And especially if we could convert it in some decimal form, but it's negative. So b cannot be negative. And any value that is being given to you to the question, you don't have to solve the question if it has an initial value of anything starting with a negative. And b, if equal to 1, will give you itself, so it's not going to be again a function. So if b is equal to 1 and they tell you whether it's b, so it's a tricky part that if b is raised to power x and b is equal to 1 in this case, you would just simply say that if b is equal to 1, then this is not an exponential function. And f3. So if instead of fx, it's f3, it means that you have put the value of x as 3 is equal to 2 raised to power x. So f3 is 2 raised to power, again, the value of x. You just put x here, 2 raised to power 3, and you get 8, which is evaluating the power. It's again an exponential function. So again, there's another example. We have a's initial value, but do remember that for multiplication, that you can't really multiply 30 with 2. So again, that they have said that you can't really do like this. You have to first of all solve the bracket and then multiply it with a constant value of a. So anything which is b raised to power x, so you have to first of all solve b raised to power x, and then you're going to be multiplying with what it by the initial value, which is a, as 30, and see the difference in the answers. Okay, so now we have another addition. You can just we've asked you to do it without a calculator in the exam. It could be, or in the assignments, if in case you're not given an exam, give you to solve something without a calculator, then you're supposed to break it down stepwise. So we have 5, 3x plus 1 in this case. So it means that any value that x assumes, substituting x equal to 2 or 3 or 4, so you just solve it first, 2 plus 1, and then see, because they have asked that if f2, evaluate this. So put this function with value of x as 2, and you have 3, and then again 27, 3 into 3 into 3, and you get 135, you multiply it with this. Round to 4 decimals. Okay, now can you do this as fx equal to 8, 1.2, and x raised to power minus 5. So if f3, so that means 3 raised to power minus 5, again this is minus 2. So raised to power minus 2 is 1 over whole twice of that, 1 over 1.2 whole square. So again 1.2 into 1.2, so it's like 1, let me just 1.2 into 1.2, and you get about, oh, hasn't done, 1.2, so let me see again, 1.2 into 1.2, get about 1.44. So this again has to be in denominator, so 1 by 1.44, and you get 0.6944. This is a very long answer. And then you multiply with 8, because that was the initial value that we had. Okay, so 8, and you get 5 points. So they just said that you have rounded to 4 decimal places, and we've done the grooves for decimal. If you have 5, you can round it up to 6, so it's going to be 5.5556, because it's just continuous value, sort of like the rational and the irrational number that we've done before. So anything which is having a constant rate, constant value after the decimal, we can accept that. But if it keeps changing, then it's a non-rational number. But anyway, that's besides the point. What I'm trying to explain to you is that we can just round it off, and for decimal value. Again, they have said that if b is not equal to 1, it's just sort of like a summary for you that any real number and positive real number, that b cannot be a negative real number. It has to be positive because it has to show growth, and a can be having a negative positive value. Now we are doing some sort of comparison between the linear function and the exponential function, for especially the interest rate that basically for initial investment. We have company A, which has 100 stores and expands by 50 new stores a year. So its growth can be represented by this linear function, because it is expanding by 50 new stores. So there are 2 stores, again 100 total. That means that 50 and 50. But that means that if it is just one time, if it is 0 times, that means that there were no stores open, or the one that was already existing has closed down. So you can just simply see the difference here. And in this case, the answer is going to be the same. The reason is because anything multiplied by 0 is in itself. So this means that it is initial, it's multiplying by the initial value. This year has not passed at the moment, so there's no expansion to be seen. So 100 plus 1.5 is 50% each year. The number of stores are increasing. So that is the main detecting factor for you to analyze between the linear and exponential functions. That see, there are 50 new stores a year, and this is the number of stores is 50% each year. And the 50% and 50 new stores is not the same thing. 50% of something could be 50% of 1 could be 0.5, but 50 and 1 would be 51. So that is the difference, as you can see here. we have initially, but you should always know that the base can give you a greater number in the future, in subsequent periods, that this answer would start increasing, even if it is not increasing initially at that, for the first period it's not increasing, because the base in this case is not, as you can see, as you can say, that it's not operational at the moment. We can mechanize it in the later one, in the later periods, as 1.5 raised to power 2, which is in the second year it's entering, is exponentially increasing with 100. And how it does is through calculator. I hope that the values of the calculator, you just simply okay, it could be this function is perhaps available in your you can just simply see that this function could be available to you in your own, in even the mobile phones that you have. It's sort of like an arrow which is going upwards, or 1 by x value, or x raised to power y value, something like that. So that function you can use to find out the basics of that. So it's 1 plus 0.5 raised to power 0. Over here, I don't think we have all the functions.
मैंने व्यू में जाके व्यू में चेंज व्यू कैलकुलेटर का व्यू में जाए.
Okay.
साइंटिफिक और प्रोग्रामिंग इसमें चले.
Okay, yes, we have x raised to power y, right? So now what we can do is 1 plus 0.5. This is 50% rise, 1.5. Again, now this is raised to the power of 2, and you get 2.25. So this is the factor which is going to be giving you. This is the base factor now. 1.5, into 2 is more than twice, and then it's going to be more than thrice, so it's going to be giving you 337. But over here, as you can see, that this is just 3 times the initial value, and then 4 the initial value of this thing. It's not 300%. So this is basically the difference. A good example for you again. This is the way that they have drawn the linear, because linear is usually constant value, and this basically is a misleading function. If you have studied statistics, you would know that it basically shows this indent means that they have siphoned off few years. Like this is the number of stores, so in this case it's going to be number of stores. Sorry, not years, but number of stores that they have siphoned off. Because this graph would have a lot of values, and this intercept would be increasing up to a disproportional height. So they have cut it off, and the way you cut it off is just by a slight indent over the intercept, and then you can just start with 100 as the base value, and then again you can have the compound interest formulas on the same lines. Yeah, start those. This page, wait a little. Okay, thank you. Let's resume. As you can see now, this is more like a proportional slope, sort of like a 45 degrees line. And this is increasing, and the slope is not constant. Here the slope is constant, but here it's not constant, because the rate of change is expressed here, but here there's an increase which is constant increase. There's no rate of change. Okay, so now, like I said, that if the domain is basically from minus infinity to positive infinity, but if you have the value starting from 0, then it will go to positive infinity. And if that x value is from 0 to 100, that means that this is going to be going from 100 to infinity. And this is expressed, and 1.5 in this case, as I already explained to you, that this is going to be the base. So the base, if there's a question also in the exercise, I believe, that we'll be going to be doing the exercise a bit later. But the base would mean that, if there's the base value is more, as in this case, yeah, okay, so there's an example here for you. So if the base value is more, it means that at the blink of an eye, you should know that, the answer should be, of a higher, value. However, the initial value is low, then your answer is not going to be increasing for either of the options in which the initial value is low. In this case, you see that the population was about 1.25 billion. This is the initial value, okay? So from 2013 and from 2031, so how many years lapsed between 18 years, right? 13, 23, and then 33, it's 18 years. So now what they've said is that the annual growth rate of about 1.2%. So it's going to be 1 plus 0.012, and it's going to be 1.012, right? Raised to power 18, because what they have said is that there's a growth rate. And when they talk about rate, you just raise it to the power for the number of years that we're going to be studying the rate of change, or whether of population or of something else. And you multiply, this is going to be 1.549. Again, you can, experiment it with some other base value, and you can see the result as, if this is 1.012, 1.012, again raised to power 18 is constant value. We have 1.24, let's say. Okay, so now 1.24, obviously, if multiplied by, what was the initial value? 1.25 billion. So now if you just multiply by 1.26 billion instead, so that means the initial value has changed. Oh, no. It was 1.24 into 1.26. Oh. And you get 1.5624. Okay, so that means that initially it was 1.549, now it is 1.56. So the base value can make a difference, but sometimes you'll be getting a question in which the number of years might be changing for the two situations. Then you have to compare with the base value what has more impact, whether the number of years exponentially or whether the initial value if changed by solving the two. Now again there's an example, and I'm again repeating, I can't stress enough that you have to do all the examples. This is similar pattern. This is just how to do things, it's just they've just given you a summary of that. So you have to solve for B. First of all you just multiply with this thing, or you can just simply put values in the initial value and then raise to power x. For any value of that you don't have here. So if it's, let's suppose, a into b raised to power 4, something like that. So 1 over a raised to power 1 by 4, because you're going to cancel the x with 1 by x, and you'll be just left with a b value. And that we have done in the functions that when we were doing factorization in polynomials, we've done that. Okay, so again, these are the tiny bit of examples that are meant for you. You just do those. I just really want that you should be able to do all this. Just giving you further examples of it. Okay, then y-intercept. Let's suppose this is another situation for exponential function graph. Y-intercept. Okay, so they have given you the the whole domain, and 0 to 3. It would mean that obviously x doesn't have a value and starts with 3 here as our first point. So a is equal to 3 in this case. Now choose a point on the curve some distance away from 0, 3 that has integer coordinates. One such point is 2 dash over 2 to 12. So that means that you go to 2 and we have 12. And that will be this value somewhat here. okay? And then again, we can have some others. So write the general form of an exponential function. When there's an initial value, just simply y is equal to 3, b x. So a is equal to 3 in this case. So now I give you this value as 0 to 3, and I ask you to, this is some initial value. Initial value basically is the intercept. Always remember this thing because it's the value, the base value that we must have. So in this case, this is the intercept. So you'll have a as the initial value if given in this form, and even if I don't ask, mention, that this is the initial value, you should automatically know that this intercept. In this case, when x is 0, naturally this has to be the intercept, and a is the intercept. And just like as in the linear function, we have a plus bx. So even then, there's an intercept here. There's an intercept as 3, b raised to the power x. So we can have substitute the initial value 3 for a, and then again. Now in the second portion, now we have values for two values, rather 2 and 12. So again y, now we have 12, so we can replace y as 12, and we already had 3, and b is that is the raised to the power x, and x in this case is 2. So the two situations were 0, 3 and 2, 12. In this case, this is the intercept a, this is going to be x, and this is going to be y. So then you solve this, substitute just the values, and again I said that now you have to take the under root for this, so b square, and we want to cancel the square, so we're going to be taking perhaps the under root of that. So the under root can have positive and negative, but since we don't take b as negative 2, we'll be using b as positive 2. And similarly, all the other functions. This is basically a graphing calculator. You're required to, you can just simply put in values by pressing start first. If you do not have the graphing calculator, you can just use any calculator and just try to plot it yourself. Okay, let's just look at this example. But first of all, let me just go to the questions. These things that we've already done in great detail. I want that you should be doing this section. There's a continuous decay. Okay, let me just give you an example of decay. What does the decay means that random decays at a continuous rate of radon. Basically, it's an element. Radon, yes, it decays at a continuous rate of 17.3% per day. So, or 0.173 is when they say that it is declining in a way that it decays. It's represented with the minus, raised to power minus. How much will 100 mg of radon, this is radon, decay to in 3 days time? In 3 days, so that means it could be 2 days, it could be 1 day, or 4 days or 5 days. That means it's supposed to be in place of x, and this is time for t, and r could be any other rate or interest or any other value that you can put if it was supposed to be multiplied by by a negative value. So it's going to be r as 0.173 negative. So we have a negative rate with the value of x, that is basically rx, and exponential value is 2.718282, like I said, and then multiplied with the initial value, which is how much will this lead to, and then you can just simply put in the value, and you can just add it and find out. Now the section, this is 476, so basically from 463 to 460, 76, 77, and 78, you have a number of questions. And then we're going to be doing the next part, which is basically the graphs of exponential functions. To some point, we've already covered this. I'm going to be doing the log side. Let's just look at a few questions so that you can just, see. Okay, now, first of all, they're asking you to explain. This is the verbal section, it's point 1, and page 476. It says that explain why the values of an while the values of an increasing exponential function will eventually overtake the values of an increasing linear function. It is, I already explained to you the answer. The reason for it is because the exponential value can have a base of b, and it has a proportional rate of change, which is increase, or an increasing rate which is proportionally changing, or increasing in its domain. Whereas for a linear function, there is a constant increase. However, that increase is not a proportional increase. Okay, it's just uh, uh, thus that increase of its original value is a constant increase of its original value. So it's 2 plus 2 plus 2, so it's a constant value increase. Whereas this is a rate which is proportional as to 100%, 200%, 10%, 3%. So this or it could be maybe a similar, since it's a constant increase, so I could just say it's 100%, and the second time it's going to be 200% because we'll be adding the rate would be added. It's increasing at an exponential rate. So it's 100 and then 200 and then again 300. So the change is constant but in proportion. So it's going to be expanding exponentially. So it's exponentially means very large. So the difference between them is quite significant. Now next you have the average annual population increase. Okay, what are they asking for? The identify whether a statement represents an exponential function. Again, if you see the average annual population increase of a pack of wolves is 25. So this is an entire domain. This change is basically spread over the entire domain, and it is the increase over the domain as a constant increase of its original value. So this is basically not an exponential function, it's going to be a linear function. 5 is that a population of bacteria decreases by a factor. Now you see that this is an exponential function because it is saying that it is decreasing, although it is a decay, and exponential decay because it is decreasing by a factor of 1 by 8 is a percentage, sort of, it's 0.125. Every 24 hours is going to be decreasing by this rate. So it is exponential decline. Now again, 6 says that the value of coin collection has increased by 3.25% annually over the last 20 years. Now again, as you can see, this is increased by this increase, always expressed in percentage, but if this is annual, the value of a coin collection has increased annually over the last 20 years. So this is going to be somewhat exponential because it has increased by this percentage annually. So 1 plus 0.0325 raised to power 20 is going to be something like a compound value. This is going to be an exponential one. And this, as you can see, this is a quadratic function because we have x as in place of the base. So we cannot have x instead of a constant. We need to have a constant here. And for 7, we have for each training session, a personal trainer charges assigned $5 less than the previous training session. This is going to be a linear function because he's charging, less than the. It's just that decrease, or the subtraction is constant of its original value, but it is not decreasing exponentially. It doesn't involve any rate. And try to attempt, the other problems I just have. So we're just, a bit short of time. I would like that as many problems I've already explained to you the intercept value. You can just simply put in the formula for exponent as a function of x. Y is equal to function of x in this case. Okay, now I just go to more, questions. We just we need to quickly just go through these a bit, proof type questions. I've already given the solution for these for you to understand. Now let's just say we have question. Okay, this is quite apparent that you can see you've already done this in our previous discussion. Go to 59. You have to just put in the value of a 1 over b. Yes, this is correct in this case because b is greater than 0, or it can be between 0 to 1. But it can be expressed as a percentage, and it can be used as an exponential decay function. for some positive numbers. So the base is use this formula along with the function that b is equal to e raised to power n. So if a base is e raised to power n, so 1 over e raised to power n, and then if you want to just put it in the, you want to cancel the this fraction form, you can just simply say e raised to power minus n. So because this is going to be this is b raised to power minus 1. So it's going to be e raised to power minus n, and then minus would go out, and you can just simply have nx outside and minus, separately written as in solution that we have here. As you can see that a 1 over bx, you just simply replace 1 over b by e raised to power minus n, and then it was initially outside, and then you have as minus n, as you can understand. If you can understand this, then you can just simply we know the power rule. That we have done in our previous lectures, that you can just multiply it with the power outside, and they can be taken out from the bracket. And this is again, there's another question for you, to maybe stimulate your mind. The formula for the amount A in an investment account. Okay, so AT is AE raised to power RT, and they have given you two functions. And this formula is a bit challenging for you because they have not mentioned it, but they have mentioned it to some point in here. As you can see in this example, PERT or AERT is one and the same thing. They have not given you one formula. Maybe you have to just sift it out from the information. Try to do this first so that you can attempt that problem. Let's just go back to the problem. If you don't understand this, just come back to me over this. What it's saying is that you have to revert this as this. Prove that the percentage of interest earned to principal at any time t can be calculated with the formula ERT minus 1. And as you can see, this we have, where have I done this part now? Okay, in here. So now, okay, this is a formula that is not probably mentioned in your chapter, but this is apparent from the value that this is the initial value of A, and then this is the change in the value, and you know that any change divided by the original can give you the rate, which is actually the annual paid value principal. That is basically the growth factor. Y to Y is actually the growth factor, or APY is the annual principal growth factor. So this is AT, this function minus the original function, and original in this case is the initial value. So as I've already told you that this is the intercept, so this is the initial value that is initially deposited into an account. So A is the value that probably when you open an account, you put in the value, then you wait for the interest to accumulate over that initial value. So that initial value can be separated from the value which has earned interest, right? So as you can see that this change, now this t is ERT, so you can just simply subtract, replace the value of t with ERT, and a ERT minus a, and then you can just take out simply, this a is cancelled by a because you just simply take a as common, ERT minus 1 over a. So this is the formula for it. You can just remember this is a proof. If given to you in the exam, I hope that you can just reproduce this. And there's another example for you. You can do the, this is a question sort of form in which the fox population in a certain region has an annual growth rate of 9%. So it's basically 1 plus I, which is 1.09 in this case. There were 23,900 fox found in the area. What is the fox population in 2020? So it's 8 years ahead of that. So you just raise to power 8, and in this case, let's see if we have done that. yes, it's raised to power 8 into this. You just simply get the value of foxes. And let's just see some. Okay, the last question. We're at 62. Okay. Now this says that a scientist begins with 100 milligrams of a radioactive substance. So in this case, your A would be 100. And that decays exponentially, so it's going to have some kind of a negative value associated with it in exponent. After 35 hours, 50 mg remains. So how many milligrams will remain after 54 hours, right? So, this is A, and then after 35 hours, let's just do this, ABX. So now we have, as I said, A is 100 mg, 35 hours, because we were doing the columns. I said that there are 0 hour, 1, 2, 3 up to 35 hours in the initial example. So, and B, you can find out the B if you feel like. Let's just see if they have found out the value of B. It's very simple. You divide, you cancel this value, just simply 50 by 100. Instead of dividing it by 100, you can just simply, because I was putting it in words, so I had to, for this step, but it's not mandatory for you to do. You can just simply, divide it and know that it's half. And this half is actually, I would say, 0.5 raised to power 1 by 35. Okay, so let's just put it 0.5. Do we have 1 by 35? So it's actually 35 root of that. Oh, I don't know, maybe 0.9803, 9060. So you can see that the answer is the same. So what you can do is just simply 1 by 35 and 0.5, 1 by 35. So just have 0.5 again under root this value to y, and then press the the value 35, that is the nth root, basically 35th root. So you can just press with the root, and then when you have this value, then you can just simply plug it in here. All the values as 100 into 0.98 raised to power, since now x is 54, so into 100, and again now we have x raised to power 54, and you get 9.8. So it's just it just shows that that this value has now has the percentile added to it. And there you go. I hope that you can revise this, and I'll be uploading this in Google Classroom for you and LMS as well. So thank you very much, class. I'll see you next time.